According to the National Electrical Code, Article 430, which addresses motors, motor circuits, and controllers, specifically Section 430.148 pertaining to indoor installations, there are requirements for water leakage protection. Subsection B of 430.148 addresses clearance from piping. Where a water pipe passes over an indoor motor control center, leak protection apparatus shall have a minimum clearance. The clearance requirements are as follows. Firstly, 18 inches or 457 mm for pipes up to 6 inches or 152 mm in nominal diameter, and secondly, 24 inches or 610 mm for pipes over 6 inches or 152 mm in nominal diameter. This code provision aims to prevent water damage to electrical equipment in the event of a pipe leak. It is crucial for electrical and mechanical engineers, as well as installers, to adhere to these clearance guidelines during the design and installation phases of motor control centers in proximity to water pipes. Understanding and applying these requirements helps maintain a safe electrical environment and minimizes the risk of equipment failure or electrical hazards due to water intrusion. The National Electrical Code serves as a comprehensive guide for safe electrical practices, and compliance with its provisions is essential for ensuring the safety and reliability of electrical installations. The requirements outlined in Section 430.148 are specifically designed to address the potential risks associated with water pipes located above motor control centers. It is important to note that the nominal diameter of the pipe refers to its approximate inside diameter and is used as a standard measure for pipe sizing. When installing water pipes near motor control centers, it is imperative to accurately measure the pipe diameter to determine the appropriate clearance. The use of leak protection apparatus is also mentioned in the code, suggesting that additional measures to prevent water from reaching the electrical equipment may be required or beneficial. This could include drip pans, shields, or other devices designed to redirect water away from the motor control center in the event of a leak. Proper installation and maintenance of these leak protection measures are crucial for their effectiveness. In addition to the clearance requirements specified in the code, it is also important to consider other factors that may affect the risk of water damage. These factors include the type of piping used, the quality of the pipe joints, and the overall condition of the water system. Regular inspections and maintenance of the water system can help identify and address potential leaks before they cause damage to the electrical equipment. When designing and installing motor control centers, it is also important to consider the location of other utilities and equipment in the area. Avoid locating motor control centers in areas where they are exposed to excessive moisture, humidity, or other environmental hazards. Proper ventilation and temperature control can also help prevent condensation and other moisture-related problems. The National Electrical Code is updated periodically to reflect changes in technology and industry best practices. It is important to stay up to date with the latest edition of the code and any applicable local amendments to ensure compliance with current regulations. Consulting with qualified electrical and mechanical engineers during the design and installation phases can help ensure that all code requirements are met and that the installation is safe and reliable. In summary, the National Electrical Code Section 430.148b specifies minimum clearance requirements for water pipes passing over indoor motor control centers. These requirements are 18 inches for pipes up to 6 inches in nominal diameter and 24 inches for pipes over 6 inches in nominal diameter. Compliance with these requirements is essential for preventing water damage to electrical equipment and ensuring a safe electrical environment. Proper installation and maintenance of water systems, along with the use of leak protection apparatus, can further reduce the risk of water-related hazards. Staying up to date with the latest edition of the National Electrical Code and consulting with qualified professionals are crucial for ensuring compliance and safety. The code's intent is to mitigate risks associated with water leaks potentially impacting sensitive electrical equipment within the motor control center. Water intrusion can lead to short circuits, equipment malfunction, and potentially hazardous electrical conditions. By maintaining adequate clearance, the likelihood of water directly contacting the motor control center in the event of a leak is significantly reduced. The specified clearances are based on the potential spray or drip pattern of a leak from a pipe of a given diameter. Larger diameter pipes are generally under higher pressure and may produce a wider spray pattern in the event of a rupture or leak, hence the greater clearance requirement. The code references nominal diameter as the determining factor for clearance requirements. Nominal pipe size, or NPS, is a North American set of standard sizes for pipes used for high or low pressures and temperatures. Nominal refers to pipe in non-specific terms and identifies the hole with a non-dimensional number. For example, a 6-inch nominal diameter pipe does not actually have an outer diameter of 6 inches. It is crucial to consult pipe sizing charts to determine the actual outer diameter of a pipe based on its nominal size and schedule. The schedule refers to the wall thickness of the pipe, which also affects its outer diameter. While the NEC specifies minimum clearance requirements, it may be prudent to exceed these requirements where feasible. Providing even greater clearance can offer an extra margin of safety and reduce the potential for water damage. In situations where space constraints make it difficult to achieve the minimum clearance, alternative solutions may need to be considered. These solutions could include routing the water pipe, installing a physical barrier to protect the motor control center, or implementing a more robust leak detection and mitigation system. Any alternative solution should be carefully evaluated by a qualified engineer to ensure that it provides an equivalent level of protection. Regular inspection and maintenance of both the water piping system and the motor control center are essential for ensuring continued safety and reliability. Inspection should include checking for signs of leaks, corrosion, or other damage to the piping system, as well as verifying the proper functioning of any leak detection or mitigation systems. Motor control centers should be inspected for signs of water intrusion, corrosion, or other damage. Any issues identified during inspection should be promptly addressed to prevent potential problems. In addition to the NEC requirements, local building codes or regulations may also have specific requirements related to water piping and electrical equipment. It is important to consult with local authorities to ensure compliance with all applicable codes and regulations. The NEC provides a framework for safe electrical practices, but local codes may have additional or more stringent requirements based on specific local conditions. Proper documentation of the installation, including the clearance between the water pipe and the motor control center, is also important. This documentation can be useful for future inspections, maintenance, or modifications. The documentation should include the nominal diameter of the pipe, the measured clearance, and any other relevant information. In summary, adhering to the NEC requirements for clearance between water pipes and indoor motor control centers is crucial for preventing water damage and ensuring a safe electrical environment. By understanding the code requirements, considering additional factors such as pipe size and system condition, and implementing proper inspection and maintenance procedures, the risk of water-related hazards can be significantly reduced. Remember to consult with qualified professionals and local authorities to ensure compliance with all applicable codes and regulations. Furthermore, the importance of proper planning during the design phase cannot be overstated. Consideration should be given to the placement of water pipes and electrical equipment to minimize the potential for conflict. Collaboration between electrical and mechanical engineers is essential to ensure that all systems are designed and installed in a coordinated manner. This includes careful consideration of pipe routing, equipment layout, and accessibility for maintenance and repairs. In existing installations where the minimum clearance requirements are not met, a thorough assessment should be conducted to determine the potential risks and develop a plan for remediation. This assessment should consider the age and condition of the piping system, the potential consequences of a leak, and the feasibility of implementing alternative solutions. Remediation options may include rerouting the water pipe, installing a protective barrier, or upgrading the leak detection system. The specific approach will depend on the unique circumstances of the installation. When making modifications to existing electrical or plumbing systems, it is important to ensure that all work is performed by qualified professionals who are familiar with the applicable codes and regulations. Properly performed modifications can create safety hazards and may violate code requirements. All modifications should be properly documented and inspected to ensure compliance. In addition to the technical aspects of clearance requirements, it is also important to emphasize the importance of communication and coordination between different trades. Electricians, plumbers, and other tradespeople should work together to ensure that all installations are performed safely and in accordance with code requirements. Regular communication and coordination can help prevent conflicts and ensure that all systems are integrated properly. The NEC is not intended to be a substitute for sound engineering judgment. While the code provides specific requirements, it is ultimately the responsibility of qualified professionals to ensure that all installations are safe and reliable. Engineers should consider all relevant factors and apply their expertise to develop solutions that meet the specific needs of each project. The NEC is a living document that is constantly evolving to reflect changes in technology and industry best practices. It is important to stay informed about the latest updates and revisions to the code to ensure compliance with current regulations. Subscribing to industry publications, attending training courses, and participating in professional organizations are all effective ways to stay up to date with the latest developments. In conclusion, compliance with the NEC requirements for clearance between water pipes and indoor motor control centers is a critical aspect of electrical safety. By understanding the code requirements, considering additional factors, and implementing proper inspection and maintenance procedures, the risk of water-related hazards can be significantly reduced. Effective communication and coordination between different trades along with sound engineering judgment are essential for ensuring that all installations are safe and reliable. Staying informed about the latest updates to the NEC is crucial for maintaining compliance with current regulations. By prioritizing safety and adhering to established codes and standards, we can create a safer and more reliable electrical environment for everyone. The location of a motor control center, its environment, and the type of water pipe material all come into play when the electrical and mechanical engineering team decide the best route to take to meet the NEC requirements. If the environment is known to have earthquakes, then you should consider an even larger buffer. While not specified in the NEC, the type of water being carried in the pipes can influence the decision as well. For example, is the water corrosive or not? Is the electrical panel NEMA rated for that environment? These are all factors to consider when deciding the best route.